Before we get too far into this video, I wanted to give you some suggestions to follow as you work along with me. Number one, listen with the volume on, right? Don't use closed captions. Don't mute it and listen to music or watch TV. You'll totally lose. Number two, treat this as a class lecture. No distractions. Again, don't try to incorporate this with a bunch of other stuff. This is math. It requires 100% of your attention. Three, pause frequently, right? To keep up and complete the work on your own. Four, make sure you ask questions via email, right? You don't have to wait for class to get questions answered. And five, looks like I forgot the number five, listen. Really listen. I give good suggestions. I'm really trying to help you be successful. All right, let's dive in. Today we're going to talk about the midpoint. And so what is the midpoint? Well, it's a point, and it's in the middle of a segment. So the distance from A all the way to C is cut in half by that point. So when you go from A to B, you're halfway. Let's get into the formal definition, right? The midpoint of a segment is a point that divides the segment into two congruent segments. Two congruent segments, right? And again, what does congruence mean? It means of like measure, right? Identical. A line array or segment that intersects a segment at its midpoint is said to bisect the segment, right? It bisects the segment and is called the segment bisector. So we have this segment bisector, right? Up here, line L is a bisector of segment AC, or as we say down here. In the diagram to the left, now I know this picture's up here, but on your handout it's to the left. Point B is the midpoint of segment AC. Point B is the midpoint of segment AC. And line L, right, L is right here, goes right through that midpoint, thus making line L a segment bisector of segment AC, or essentially, it cuts AC in half. So what do we do with these halves? Well, we have this idea of the segment addition postulate, right? And we say that PQ plus QR equals PR. So PQ plus QR equals PR. But that doesn't do us any good because we don't know anything about PR. Yeah, we have some information about PQ, we have some information about QR, but we don't know anything about PR. It's not given to us. But what was given to us is that Q is the midpoint of PR. So I know that this piece and this piece are identical. And so now we have some new algebraic options. And that option is going to be, if they're congruent, set them equal. Well, don't forget, first off, we have a symbol for congruent. That symbol means congruent. So I know that if Q is the midpoint of PR, that segment PQ is congruent to segment QR. And if that's true, right, then the length of PQ is equal to the length of segment QR. And now I'm going to substitute in my second string players and say, well, 7x minus 16 is PQ. That's equal to QR, which is 4x plus 2. Now what? Solve for x, and we're done. So I'm going to choose to subtract 4x from both sides. 7x minus 4x is 3x. Negative 16 drops down. Right? I'm staying on that line. That drops down. And I get 3x minus 16 equals 2. Add 16. Add 16, and I get 3x equals 18. Divide by 3, divide by 3, and off to the side I'm going to get x is equal to 6. And I have a final answer. My check, I'm going to take that 7x minus 16, right? This statement right here, setting equal to 4x plus 2. Well, I said that x equals 6. So if I take 6 and substitute it in for x, take 6, substitute it in for x, I get 7 times 6 is 42, minus 16 is 26, 4 times 6 is 24, plus 2 is 26, 26 equals 26, so yes, that's a good answer. Let's try that again. if h is the midpoint of gi, so h is in the middle of gi, which means that this and this are congruent. And that little red tick mark is how we identify things that are congruent. So I'm going to say, well, GH is equal to HI because of this midpoint information. And if GH is equal to HI, then I can substitute in known values. Subbing in for GH is 5x plus 2. Subbing in for HI is 9x minus 10. Now what? We're going to go slow and easy, right? Subtract 5x from both sides. And why do I choose to subtract 5x? Because I want to keep my coefficient of the variable expression positive, right? These are my coefficients, the value attached to the variable. I'd like to keep that positive if I can. So I take my 2, drop it down. 9 minus 5x is 4x. Negative 10 drops down. I'm going to add 10 to both sides. And the reason I chose to do that is because I push my variables to the right. 12 equals 4x, cleaning it up from left to right. Divide by 4, 3 is equal to x. Okay, am I done? No, they want me to find GH. So GH is going to be equal to 5x plus 2. So GH is equal to 5 times that value of 3 plus 2. That's 15 plus 2, which is 17, is equal to GH. And we are all set skis. So I'm going to get you going on this one, but you're going to finish it. So first we notice that R is the midpoint of QS. So I know that these segments are indeed congruent. So I'll mark them congruent, and I'll say that QR is equal to RS. And so that means that I can substitute in these pieces, and I can work my way down, and I can get a value for X. Now what? We want the value of QS as our final answer. It says find QX, or QS rather. That's my final answer. QS, I notice, is the length of this whole piece. So we don't have one thing we could substitute in to find that. I guess I'm going to have to use the idea of the segment addition postulate that says, well, QS is equal to QR plus RS. And I know how to find the length of QR. It's 2 times, right? You're going to find this value of X, 2 times that value plus 16. And I'm going to add that to RS, which is 5 times that value minus 17. Now just keep in mind that this whole value and this whole value should be the same because this is QR, this is RS, and we set up here that they were the same. Don't just multiply QR times 2. Make sure that you check your algebra and then get your final answer for QS. That's your mission. Now this last one, I'm going to walk you through it. G is the midpoint of FH. Okay, so G is in the middle of FH, so no problem. We say FG is equal to GH. And we take 4x plus 3, that's fine. And we can set it equal to 7x minus 12. And we do a little bit of algebra here, and let's see if we get the value of x. We're going to subtract 4x, subtract 4x. And we get the 3 comes down, 3x minus 12. We add the 12, we add the 12, and we get 15 is equal to 3x divided by 3, divided by 3. 5 is equal to x. Not a problem. So the next thing it says is find y. Y? Where'd y come from? Y has to do with FH. So this whole length is FH. So 6y minus 2 is equal to what? This entire length. Well, I know that entire length is FG plus GH, which happens to be 6y minus 2. FG is 4x plus 3, but I know what x is. It's 5 plus 3. I add that to 7x minus 12, which is 7 times 5 minus 12. So now let's do some number crunching on the right side. We don't have any x's, so this is a true and solvable program. Got 4 times 5 plus 3 is 23. That's all that. And 7 times 5 is 35, minus 12 is 23 again. And we knew that because we said FG was equal to GH. So 6y minus 2 is equal to 46. Add 2. We get 6y is equal to 48. Divide by 6, y is equal to 8. Not too shabby. Is it totally out of reach? Not really. Is that a challenging question? Yeah, I'd say that's sort of like a bonus level question. It's a good one though. It's a thinker. That about does it for us for notes on the midpoint and segment addition postulate at this point. So we got some good algebra practice under our belt, and we're ready to do some more practice.